Second video for the quadrilaterals review. So we have parallelogram. So let's just highlight that. It gives us a lot of properties that we could use. And then this AFD triangle is isosceles with AF the same as AD. The measure of EBC is 52 degrees. All right, we could use this way. So these two are parallel. And if we had parallel lines cut by a transversal, we actually didn't need that other one. Let's get rid of that one. What we know is that these positions are corresponding, and corresponding angles are congruent when these lines are parallel. So this angle A is 52 degrees. We could do 180 minus to get this one. Yeah, let's just do that. So these two are supplementary here. So 180 minus 52 is 128. Now, this angle, this angle right here now is also going to be 52. You know what? I could have just done alternate interior angles. So either way, the measure of angle ADF is 52 degrees. And because of this being isosceles, the measure of angle F is 52 degrees. Okay, so let's go through the justify just to make sure that I don't lose credit anywhere. Okay, the angle EBC is congruent to angle BAD, corresponding angles. Now, I don't have to have a full-on proof for this because I'm just justifying. All right, so I don't have to go into great detail. Just why did I use them as congruent? I'm going to use also angle BAD. It is congruent to angle ADF. That's alternate interior angles. I'll just throw the congruent symbol there. Then angle F is congruent to angle ADF, and that's base angles theorem. So that's kind of my justification. All right, next, trapezoid. So AB is parallel to DC, BD is drawn. Okay, so this top one up here, right there, 20 degrees and 70 degrees. Okay. First, we're looking for the measure of angle BDC. All right, it looks to me like they want to talk about, let's just really try to break this problem down. So this is angle B, right? We'll call that A, B, and then this is D over here. All right, we're going to try to isolate this a little bit. If you just focus on this, right, what you have is this 20 is alternate interior to that angle there, which is also going to make that 20. Okay, and then we want to find the measure of angle DBC. There's a couple ways we can do that. So let's first A, measure of angle BDC is 20. You're going to use alternate interior angles theorem. Congruent, whatever. And then for B, what we're going to do is one way to do it would be to add the angles of a triangle up to, oh, I could have done that. Whoops, 180. So focusing on that, and we want that one. So we're going to say 20 plus 70 is, that seems strange, 90. 180 minus 90 is 90. So then we get the measure of angle DBC is 90 degrees. So there it is. Okay, let's see. All right. Isosceles with these the same. Okay. all remaining angles. Okay, so let's try to figure out what we're looking at here. It looks like this one's 30 up here. If that one's 30, then this one's 30. So we should get the measure of angle EGF is 30 degrees. Okay. Okay. The measure of angle. Now let's get this top part. So basically, this 75 and this whole angle, the measure of, I'm going to just write this down, DGF is 75. So then the top of that, measure of DGE, that's going to be 75 minus 30, 45. So if we just isolate that, let's just focus on that for a minute. What we have is the whole angle 75, so that's broken down into 30 and 45. That's what I'm focused on right there. Those angles at G. Okay, so that's this one. All right, now the upper angle D. Okay, what we'll do is we'll say measure of angle D. That's going to be 105. That's because of 180 minus 75. Okay, and those are consecutive angles. All right, anything else? Probably they want this one. It's the only one I might be missing. So I'm just going to do 105 minus 30. So the measure of angle GEF. And that happens to be 75. Okay, just subtracting those. Oh, maybe the measure of angle, the big one here, DEF is 105 because it's isosceles. All right, good enough. That should be all of them. All right. It's a parallelogram, so there's no guarantee that it's a rhombus or a rectangle. Which must happen? Triangle PMS and PMQ. That doesn't have to happen. This would have to happen in a rhombus, but they only said a parallelogram, so that one's not 100%. PRQS, those are, again, that's a rhombus property for number 1. We don't have to have that. PM congruent to RM, that has to happen because the diagonals bisect each other. So 2 has to happen, but let's just check 3 just to make sure. PQ, does that have to be congruent to QR? No, again, that's a rhombus feature. So don't have to have it. Good. All right, now this one, which is always true. Okay, we got some more to work with here. Which feature is always true if it's a rhombus? So we know we have all right angles. Is AB congruent to AC? But it can't be actually because that's a hypotenuse of a right triangle and it's got to be bigger. That's got to be false no matter what. Well, as long as it's a rectangle, it's false. AB the same as AD, that would make it you'd have to have that in a square. This just has to be a rectangle, so it doesn't always have to happen. Let's see, DAC and BAC. No, the diagonals don't have to bisect the angles. Again, that's a square or a rhombus. DAC congruent to BCA, yeah, that has to happen. Okay. Keep going here. Maybe we'll get a couple more in there. Which description does not guarantee that a quadrilateral is a square? Okay, both a rectangle and a rhombus, that is. Remember, it's not. So that's going to, this is gonna force it to be a square. Parallelogram with perpendicular diagonals, that's only going to be a rhombus. So we're looking good there. It has all right angles on all sides. That is a square. It has all sides and all angles. That's crazy. Okay, so it's choice 3. That'll be good enough for this video, and then we'll pick it up on the next one.